Hi, this is Math 1340, and this video is over section 2.7, which is on inverses. Inverse function or inverse equation undoes what a function or a relation did in the first place. So it takes the outputs back to the inputs. So if you think about a normal equation, it takes values that we put in for x, sends it to, just say y for now, y. And if it's a function, then every x value has a specific y value it goes to. Okay? And um, maybe different x values will go to the same y value, but all x values goes to one y value, and that makes it a function. If that's not the case, if a single x value goes to multiple different y values, then you only have a relation. So kind of like some graphs here. So if we have something like this, that specific x value could go to either y value, positive one or negative one in this case. That's only a relationship. But there's still an inverse to it, where that would take either one of those y values back to that x value. Whereas a quadratic, every x value has a specific y value it goes to. And there may be multiple values, same y value. There are multiple x values that go to the same y value, but every x value has one y value to go to. So let's say we have original function or original equation. We'll start with that. Has 3 points, -2, 0, and 3. -2 sends, the function sends it -2 to 2. Function sends 0 to 4, and the equation sends 3 to 7. Inverse is going to do the opposite. It's going to take 2 and send it back to -2. It's going to take 4 and send it back to 0. It's going to take 7 and send it back to 3. All right, so with this data, this is from, a function that would be y equals x plus 4. Okay, it's adding 4 to everything. Inverse would be y inverse, put y to the negative first, equaling x minus 4. Okay, it's sending everything back. So 2 subtract 4 equals -2. 4 you subtract 4 equals 0. 7 you subtract 4 equals 3. Right. So how do we find it? Well, we go through a little bit of a process. So we start with the original, y equals x plus 4. We interchange the x and y. So these switch positions. We have x equals y plus 4. Then we solve for y. So we get y equals x minus 4. And then we can call that y, in particular, y inverse. Or if it's a function, inverse function. Okay. So let's do a couple of these. Switch x and y. You get x equals y squared minus 3y. If it's possible to solve for y, we solve for y. In this case, it's not really possible. So we're going to just leave this as the inverse function, or inverse equation. The next one, switch your x and y. And then we could take the q. Well, actually, let's divide by x first. We can take the cube root. So we get y equals the cube root over x, which is going to be 2 over cube root of x. Okay. There again, this is your y inverse. It ends up being its own equation. Right. So what happens if you have a function that is, well, first of all, what happens if you have an equation that's a function? Well, you have an equation that's a function. Do a couple of these. Then for every x value, there's a specific y value. That x has that y, this x has that y, this x has that y. If it's not one-to-one, then you're going to have multiple multiple x values give you the same y value. So in the quadratic is not one-to-one because there are multiple x values that give you that same y value. X1 here and x2 here give you the same y value. In a linear line, every y value is going to be different. Okay, what it means to be one-to-one is every x has a specific value. Okay, so x1 equals y1, x2 goes to y2, x3 goes to y3. You have no y's that repeat. One way we can see if it's one-to-one is very similar to the way we tell if it's a function. If it's a function, then a vertical line passes through only one point. If it's one-to-one, then a horizontal line and a vertical line will only pass through one point. The vertical line tells you it's a function, the horizontal line tells you it's a one-to-one function. So the quadratic is not one-to-one, there's multiple points that it may pass. So, by f of x equaling x squared, there's multiple points again. And so this is not one. Absolute value of x minus 3. Let me draw the bracket first. X minus 3 was shifted here, the V shape. So horizontal line passes through 2 points, not 1, 2, 1. H of x equaling 2 over x. This. No horizontal line will pass 2 points. So this is, yes, 1, 2, 1. Right, so what does that mean? Well, if your function's one-to-one, then both the function and its inverse are functions. Okay? So, in other words, your inverse also passes the vertical line test. And so we can say, okay, well, we'll have f of x then for your function and f of x with the -1 as a superscript be your inverse notation. Okay? This f with the superscript of -1 does not mean 1 over f of x. It just means that you're looking at your inverse function. The domain for your function is going to be your range for your inverse function. And your range for your function is going to be the domain of your inverse function. So your domain and range switch, basically, because your x and y's are switching. And what ends up happening is that if you graph the both of them, they end up being a reflection of each other across y equals x. And we'll see that when we do some graphing. Right, so how do you find it? Well, we kind of already went through the process. You start with just y equaling x plus 5, switch your x and y, and then solve for y. In this case, we always have to be able to solve for y, otherwise it wouldn't be a function. And then we replace back our y with inverse f of x equal to x minus 5. Okay. Good thing is we can always check these. We plug the inverse in to a function, so we are looking at f of inverse of x. We will get x out. And we only have to do it one of the ways. We get x out, we know we have the inverse, but it works both ways. You plug in f of x into your inverse, you still get x out. So g of x equaling 3 over x minus 1. Y equals 3 over x minus 1. X equals 3 over y minus 1. Multiply the y minus 1 up. Y by x. And then subtract 1. Or add 1 to both sides. You get 3x plus 1. So your inverse function is equal to 3 over x plus 1. Okay, we want to check it. We can do g of g inverse of x be 3 over x plus 1 minus 1. So this would be 3 over x, which is going to be 3 over 3 times x, which is going to be x. Next one, y equals x square root 9 minus x squared. Switch your x and y. X equals y square root 9 minus y squared. Now to do this, we're going to want to get these y's together. But that's really not going to be possible. Even if we squared it, when we square the square root, we'll have a square root there. So let's see what this graph looks like. Right, so x under the square root 9 minus x squared. I'll just do a zoom standard. And we see that if we draw a horizontal line at the top or the bottom, it's not passing the horizontal line test. Okay. That means that this is not one-to-one. Okay, so this is all we have to do. This is your inverse, and it's not a function. The inverse is not a function. All right. So again, if a function is one-to-one, then the function and the inverse, the composite, will equal x. So if we take f of x equals 8x plus 5, composite is x minus 5 over 8. To show that, we can plug these in. This going 8's going to divide out. You get x minus 5 plus 5, which equals x. And if we go the other way with this, x 8x plus 5 minus 5 over 8, 8x over 8. All right. So what happens if a function is not one-to-one? What can we do? Can we do anything? Well, there is one thing we can do, and we can restrict the domain so it is one-to-one. And we just have to make sure we note that. So let's take x squared minus 9. Let's look at the graph. I'm going to graph it on the calculator. So x squared minus 9. Graph it, you get quadratic. And so we want to restrict the domain here. We want only x greater than or equal to 0. Right now, it's not passing the horizontal line. So, to do that, gotta remember how to do it. um, x there's one called logic. I'm trying to find where it is. Yeah, there you go, logic. Um, greater than or equal to 0 should work. Try it right another way. So I just took a bit of time. I think it's the comma there. It's not supposed to be a comma. I'm trying to remember what it's supposed to be. I think it's supposed to be a decimal colon. All right, it's fine. We can just kind of draw it where it doesn't include that. We're only going to include y greater than y greater than um, 0 or equal to 0. So that's equal to, greater than would be everything on this side. Okay. Now it's 1-to-1. What's that mean for the inverse? Well, in this particular case, we have y equals x squared minus 9. Switch your x and y, add 9 to both sides, then take the square root. We have y equals square root of x plus 9. So inverse of f of x is going to be square root of x plus 9. Okay, so we can graph that as well. And it's only the positive one because we restricted the domain here. Another way to do so we don't see it. 0 to 10. Okay. And so there's the first one, and there's our square root. I see. I still want this coming out some. So let me plot it on here. So -3 would give us 0, 1, 2, 3. Then 0 will give us 3, 3. So it looks like this. And then these are mirrors of y equals x. We can kind of see that if we graph then y equals x as well. Unless they cross at one point even. So let's look at this next one. We have 0.5 cubed minus 4. New standard. That's what it looks like. This is 1-to-1. We want to find the inverse of it. So y equals 1/2 x cubed minus 4. X equals 1/2 y cubed minus 4. We get 2x equals y cubed minus 4. 2x plus 4 equals y cubed. Y equals the cube root 2x plus 4. Inverse function is now cube root 2x plus 4. Graph that. 2x plus 4 raised to the 1/3. Graph it. See, these are mirror images. Plus y equals x. So let's plug in x. You can see the mirror images across this. This y equals x. In between, there's a point where they cross, and that's y equals x crosses. Now x minus 2 over x plus 5. Y equals x minus 2 over x plus 5. So x equals y minus 2 over y plus 5. We'll multiply the y plus 5 over, so we have y plus 5 times x equals minus 2. Yx plus 5x equals 2. Subtract the y over. Yx minus y equals -2 minus 5x. Pull out a negative sign, I'm going to pull out a y on the left side. So y times x minus 1 equals negative times 2 plus 5x. So y equals negative 2 plus 5x, x minus 1. So f inverse x, negative 2 plus 5x, x minus 1. So we can graph this. So first I'm going to graph x minus 2 divided by x plus 5. Second one, the graph negative 2x, what was that, 2 plus 5x, divided by x minus 1. This is harder to see. And we have an asymptote even. Let's do this. Turn this off. 8, 2. Turn this one off too. Let's see what this graph looks like. But it is 1-to-1. And so when we look at the next graph, notice it's flipped. So this part mirrors the part that was over here. So let's turn them both on now that we saw them separate. So this part on the left mirrors this part on the right. And this part here mirrors this part here. So our y equals x goes right through these 2 points here, going right through the function. Okay, so these are inverses. It's just harder to see because the way the graphs are. All right, so one more problem for this section. Cost per person for chartering a bus is given by C of x equaling 200 plus 15x over x. Well, x is the number of people in the group. Determine inverse of the cost and explain what this represents. So we'll have y equals 200 plus 15x over x. Switch your x and y. 200 plus 15y over y. Now we'll solve this for y, so we get 200 over y plus 15. Subtract the 15 over, and multiply by y, and then divide by x minus 15. Okay. And so your inverse of this cost is 200 over x minus 15. So we can check this. 200 plus 15 times 200 over x minus 15 over 200 over x minus 15. Okay. If we multiply by this, we flip the fraction to multiply, we get 200 plus 15 is 200 over x minus 15. And then that whole thing is multiplied by x minus 15 over 200. So we'll have 200 times x plus or x minus 15 temperature over 200. And then these cancel when we distribute it to the second term, so we get just 15. The 200s cancel, so you get x minus 15 plus 15. That's going to equal x. Okay, so they're inverses. But what does it mean? Okay, well, think about what x is. X in the beginning is the number of people. And C of x is the cost. And when we reverse it, we're reversing what things are. So in the new one, x is the cost, and C inverse of x is the number of people. So let's say we wanted to know how much it will cost for 10 people. So x equals 10. C of x equals See, 200 plus 150 would be 350. 10 would be $35 person. However, if we want to say, okay, well, the cost is going to be $35 per person, that's what we want the cost to be set at, and how many people can go. And so we'll do 200 over 35 minus 15, which is going to be 200 over 20, which is going to be 10. 10 people go. And so what C inverse is the number of people it would take for a specific cost. All right. The last section of 2.8 is going to be the distance and midpoint formulas, as well as looking at some circles. I'll see you then.